Hello my dear students, welcome to Ekaksha classes. Let's begin the chapter Arithmetic Progressions, which is one of the very important types of sequences. Let's have a look at what we are going to learn in this session. In this session, we are going to discuss definitions of sequence, progression and arithmetic progression. And also we'll discuss arithmetic progression and its nth term, that is also called as general term. So as part of this, we'll discuss nth term of NAP, that is general form of NAP, that is derivation, and types of problems based on nth term of NAP and nth term of NAP from the end. So these are the main topics we'll learn as part of arithmetic progression and its nth term. Okay, and also we'll discuss sum of first n terms of NAP and arithmetic mean. As part of this, sum of first n terms of NAP derivation, types of problems based on sum of first n terms of NAP as well as arithmetic mean. And finally, we will also learn applications of arithmetic progressions in real life, or we can say day-to-day life situations. Now, let's enter into the concept. You must have observed that in nature, many things follow certain pattern, such as petals of a sunflower. You can see they are following some pattern, right? The holes of a honeycomb, the grains on a maize cob, you can see the spirals on the pineapple, and you can see many such patterns in the nature. These are all you can see. Okay, not only these, you can see plenty. Okay, almost the nature follow certain patterns. Okay, not only in nature, some patterns which occur in our day-to-day life also. For example, in our childhood, we used to construct pyramids with the help of playing cards, right? You must have played. So in this, the first row from the bottom contains n triangles, and the second row from the bottom contains n-1 triangles, and the third row from the bottom contains n-2 triangles, and so on. So they follow certain pattern. You can see in the bottom, in this figure, we have 4 triangles. In the next row, we have 3 triangles. In the next row, we have 2 triangles, and so on. So in all these examples, all these follow some specific pattern. So in this chapter, we will see some of these patterns in which the succeeding term is obtained by adding or subtracting or multiplying or dividing with a specific number to the preceding term. Usually, these patterns are called sequences. Let's have a look what exactly a sequence. Sequence, that is list of numbers. An arrangement of numbers in a definite order according to some rule is called a sequence. What is a sequence? An arrangement of numbers in a definite order according to some rule. According to some rule is called a sequence. Or we can say a pattern of numbers in which succeeding terms are obtained from the preceding terms by adding or subtracting or multiplying or dividing a fixed number is called sequence, and which follows some order, that is either increasing or decreasing, right? Here are some examples of sequences. First example, you can see 1, 2, 3, 4, 5, 6 and so on. In this sequence, each term is one more than the term preceding it. You can clearly see that. Second example, 2, 4, 8, 16 and so on. In this sequence, each term is obtained on multiplying the preceding term by 2. You can see 2 times of 2, 4, 4 times of 2, 8, 8 times of 2, 16, and the next time you will get 16 times of 2, 32 and so on, right? Next example, 1 over 2, 2 over 2, 3 over 2, 4 over 2, 5 over 2 and so on. In this sequence, each term is obtained on dividing the preceding term by 2. Clear? So here we can see 3 different scenarios, right? So these are all examples of sequences. Now, sequences are 2 types. What are they? Finite type, that is finite sequences, and infinite sequences. So what are called finite sequences? A sequence containing finite number of terms is called a finite sequence. So for example, 1, 2, 3, 4, 5, 6. So it ends here. So it is fixed. Okay, this sequence contains fixed number of terms, so it is a finite sequence. A sequence containing infinite number of terms is called an infinite sequence. So for example, 1, 2, 3, 4, 5, 6 and so on. It is continuing. So it is an infinite sequence. Clear? Usually in sequences, these list of numbers, each one is called a term. Now let's discuss what exactly terms of a sequence. Terms of sequences. In a sequence, each position or number is known as a term. We denoted by the A1, A2, A3, A4 and so on, AN, or we can also denote it by T1, T2, T3, T4, T5 and so on, Tn. You can represent either way. Here A1, A2, A3, A4 also represent terms. Here T1, T2, T3, T4 also represent terms. So let us see some examples. For example, 2, 4, 6, 8, 9. So in this sequence, so here I took a finite sequence. This is A1, this is A2, and this is A3, and this is A4, and this is A5. That is first term, second term, third term, fourth term, fifth term. Position of the term. We can also say this is T1, T2, T3, T4 and T5. So let us take another example. 3, 4, 5, 6, 7, 8 and so on. So in this is A1, this is A2 and this is A3 and this is A4 and this is A5 and this is A6 and so on. The same we can also represent T1, T2, T3, T4, T5, T6 and so on, right? So in a sequence, each position or number is known as what? Term of a sequence. Clear? Now let's see some example questions based on terms of sequence. Okay, write the first three terms in the sequence defined by the following algebraic expression. Here an is equal to 3an plus 2. So this represents a sequence. In this sequence we need to write first three terms. For that we need to replace n as 1, 2 and 3. Okay, so a1 is equal to 3 times of 1 plus 2, that is 5. A2 is equal to 3 times of 2 plus 2, that is 8. A3 is equal to 3 times of 3 plus 2, that is 11. 3 times of 1, 3 plus 2, 5, 3 times of 2, 6 plus 2, 8, 3 times of 3, 9 plus 2, 11. Clear? So these are the first three terms of this sequence. Okay, let's say another example. What is 18th term of the sequence defined by? Again algebraic expression. In this we need to find 18th term. So for that we need to replace n as 18, right? So A18 is equal to 18th position term, that is 18 times of 18 minus 3 over 18 plus 4. 18 times of 18 minus 3, 15, and here 18 plus 4, 22. Again here we can divide both numerator and denominator with 2, 9s are 2, 11s are. 9 times of 15, that is 135 over 11. So therefore 18th term of this sequence is 135 over 11. Clear? This way we can find a particular term of a sequence, right? Let's see what are progressions. If sequences follow specific pattern, then those sequences are called progressions. We know if list of numbers follow some pattern, they are known as sequences. If sequences follow some specific pattern, they are known as what? Progressions. Or we can say, if every term of a sequence except the first term has a common relation to the preceding term, of it, okay, then that sequence is called as progression. Clear? Let's see some examples. First example, 1, 2, 3, 4, 5 and so on. So this is a sequence, particularly it is a progression because each term is obtained by adding 1 to its preceding term. So we can say this is plus type. Here it is next progression, 3, 9, 27, 81 and so on. In this, each term is obtained multiplied by 3. Here it is third progression. In this, each term is obtained divided by natural number. So based on these examples, we can say Again, progressions are classified into 3 different ways. You can say this is addition type, multiplication type, and what? Division type. So, types of progressions. Progressions are classified into 3 types. First one, arithmetic progression. In short, we can say AP. Example, we can see 1, 2, 3, 4, 5 and so on. Here, each term is obtained adding 1 to its preceding term. Okay. Second one, geometric progression. In short, we can say GP. So, let us take an example 3, 9, 27, 81 and so on. Here, each term is obtained multiplied by something, multiplied by 3. And the third one, harmonic progression HP. Here each term is obtained by dividing by some natural number or some condition, whatever it is. So, progressions are classified into 3 types. One is arithmetic progressions, another one geometric progressions, and third one is harmonic progressions. So, especially in this chapter, we are going to discuss about arithmetic progressions. So, let's discuss more deeply about arithmetic progressions and their applications. Arithmetic progression. An arithmetic progression AP is a list of numbers in which each term is obtained by adding or subtracting. Only 2 things, okay? Adding or subtracting a fixed number D to the preceding term except the first term. Here the fixed number D is called common difference, okay? The general form of an AP is A plus D, A plus 2D, A plus 3D, A plus 4D and so on. Here A is first term and D is common difference. You can see each term is obtained by adding D to its preceding term. Here D is added, we got A plus D, D is added, A plus 2D, D is added, A plus 3D and so on, right? The fixed number D is called common difference and this is how we can calculate D. What is that? D means common difference, that is the difference between any 2 consecutive terms. So, you can find this way A2 minus A1 or A3 minus A2 or A4 minus A3 and so on, AN minus AN minus 1, and all these must be equal in an arithmetic progression, right? So, these are examples of arithmetic progression 2, 4, 6, 8, 10 and so on. So, you can see in this first example each term is obtained adding 2 to its preceding term. You can see this is decreasing sequence. In this each term is obtained adding minus 3 to the preceding term. So, you can see in this all terms are equal. So, adding 0 to the preceding term we are getting or we are obtaining the next term, okay. So, based on these examples we can conclude. Remember that D can be positive like in first example, negative like in second example, 0 like in third example. So, D can be positive, negative or what? 0 also, right? So, this is about arithmetic progression and introduction. So, in the coming sessions we will discuss about nth term of NAP and its applications and some of n terms of NAP and their applications. Clear?